going by pretty quick. All right, so what we're trying to do at this point in time is build our understanding of math, our ability to perceive it, like Van Gogh, and also to use logic and reasoning and employ it to the real world around us. In the beginning, we kind of built up this means of perception, and we'll continue to do that throughout this semester. But more and more, we start shifting our focus toward applying it to the real world around us. Typical week this week, we have videos, we have assignments, and at the end of the week, you'll have a quiz. Okay, so what we're going to talk about today, scientific notation, as it is an extension of the laws of exponents. So if you understand the laws of exponents, you already understand most of scientific notation. Word problems, homework answers, and do it. So here's the homework answers. I am going to ask that you do stop and start. And all of these questions are pretty straightforward. So if you are not able to get these right, and it was more than a careless mistake, make sure you reach out to me to go over it. Okay, now that you've paused the video and looked over this part of the homework answers, let's try the rest of it. Okay, so we've gone over the homework. I can't emphasize enough. It's never enough to just do the homework. Okay, that's like going to the doctor and getting diagnosed. Now, to take your medicine is to go back and work on the kinds of questions you're getting wrong. If there are any that you're getting wrong, then reach out to a classmate, reach out to me, watch videos again. If necessary, go on the internet. Maybe someone explains it in a way you understand better than I do. If that's possible, please listen to them. Whatever it takes for you to understand this material, okay? All right. Today's do it. Go ahead, get started. We got 6 questions for you to do here with multiple parts on some of them. Stop and start. I'll go over the answers starting in a minute. Okay, so which properties illustrated below? What I notice here, this is a tricky one. In the parentheses, they both say 8 plus 11. And what's really changed here is the 3 went from in the beginning to at the end. So what's happened is you've switched the order. That's the commutative property of addition. Next one, I have to distribute the 3 to 3x squared minus 7x plus 4. And then double distribute x minus 5 times x minus 2, which that little part of it works out to x squared minus 7x plus 10. Then I need to put all of the terms together. That gives me 10x squared minus 28x plus 22. Explain what adding fractions and lining up decimals has in common with adding puppies and kittens. Well, we had questions like this on your project. What's so important to understand is the only way to add on the face of this earth in the universe is to add things that are alike, that have, if you will, a common category. So when you're adding fractions, you have to get a common denominator. That's a common category. Remember when we first introduced it, we actually wrote the denominators as words. And then when you line up the decimals, you need to do that because that puts the ones with the ones, the tens with the tens, the tenths with the tenths, the hundredths with the hundredths, the thousands with the thousands, and so on and so forth. Okay? So it makes sure that you're grouping like things together. Just like you can add puppies with puppies, you're going to get puppies. Kitties with kitties, you're going to get kitties. But you can't add puppies and kitties together unless you broaden out and find a common category like pets, mammals, or cute little furry things that make a mess in the house. Okay. Number 4, solve for n. This is new because we just started equations in our last week. Okay, for this one, negative 15. For letter B, the answer is 5. So on 4a, don't forget to distribute. You get 3n plus 21 equals n minus 9. Okay. And for letter B, you're going to get 3n, and then, because this is a same side, same operation situation, 3n minus 3 is 12, and that works out to be 5. Simplify each using the laws of exponents. For a, we multiply coefficients, add exponents. That's negative 15, x to the third, y to the 8th, z to the 7th. For b, it's this division here, negative 2, A, B to the 7th, C to the 4th. Remember, you divide coefficients and subtract exponents. And for letter C, it is possible to do this in two ways. One way is to remember when you raise a power to a power, you multiply. So you take the coefficient and do the operation, just like on all the others. And then when you raise a power to a power, you multiply. That gives you negative 8n to the 9th. Or you could rewrite it. To cube something means to multiply it by its, or use it as a factor 3 times. So that would be negative 2n to the 3rd times negative 2n to the 3rd times negative 2n to the 3rd. And then just apply the principles of part A. All right, so we've gone over your homework. We've talked about the important stuff during the class. We've given you an agenda for class. We've done some do-it questions to reinforce what we've been doing during the day. And remember what I said, I don't care how fast you learn it, I just care that you learn it. So we're constantly spiraling materials in this course. And now we get to praxis power. Performance is a function of preparation. We want to prepare you for that test, all who are going to take it. And if you're not going to take it, this is still beneficial for you because it covers many of the topics that we do in this class anyway. All right, here you go. Start it up. Okay, doing a little stop and start here. The correct answer is the measure of angle B is half the measure of arc AC. Since the measure of angle B is, the measure of angle B is 12. I changed it here. This should say 12, so the arc is 24, which makes the angle 24. And that's the correct answer. So ignore the explanation here. The explanation is that angle ABC is 12. That's this angle in here. That makes this arc 24. So then the central angle is the same. It's also 24. Okay, so let's use the Pythagorean theorem. Remember, a squared plus b squared is c squared, or leg squared plus leg squared is hypotenuse squared. Okay, here you go. There's all the work shown properly to get the correct answer. Right? 6 squared plus b squared is 10 squared. Subtracting the 36 from both sides, you get b squared 64. Square root both sides, b is 8. Okay. Now, linear equations. We talked the other day how a linear equation is like a scale. You have to do the same thing to both sides and constantly break it down so that you get the letter on one side and the number on the other. Okay. We did questions exactly like this, so let's have you do numbers 1, 2, 3, and 4. Okay, doing stop and start. Here's the correct answer for the first one. 8x's and 4x's make 12x's. So 12x minus 1 is 23. Remember, do opposite operations for the 1. It was the same side, same operation with the 8x and 4x. That's how you got the 12x. But now the numbers are on opposite sides, so we do the opposite operation. 12x is 24, dividing by 12, x is 2. For the second one, now this is an inequality, so we have to be a little careful here. Subtract 8 from both sides. X over negative 2 is greater than 7. And then I actually made a mistake here, so let me correct it right now. X over negative 2 is greater than 7. You have to multiply both sides by negative 2. X is less than negative 14. For number 3, 13 is 4 minus 3x. Subtract 4 from both sides. Remember, this is danger, 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 because that 3x is negative. I get 9 is equal to negative 3x. Dividing by negative 3, I get x is negative 3. As for the last one, danger, we got inequalities here. Subtracting the 12, right? This 12 is positive. I get 8 is less than negative x over 5. Now I need to multiply both sides by a negative 5. That gives me negative 40 is greater than x. But we always want the x on the left. So we move the x to the left. And if it points to the x here, It's got a point to the x here. Negative 40 is greater than x is the same exact statement as x is less than negative 40. So there's a nice little review of fundamental inequalities and equations. Now let's get into some little more challenging ones. Go ahead, give it a shot. Okay. Distribute the 5, distribute the negative 3. That gives me 5 times 2n is 10n. 5 times negative 3 is negative 15. Negative 3 times 3n is negative 9n. Negative 3 times 7 is negative 21. Equals 4 minus n. 10n minus 9n is 1n because this is the same side, same operation situation. And negative 15 and negative 21 is negative 36. So n minus 36 is 4 minus n. Always start with the smallest number of n's, so I'm going to add n to both sides. That gives me 2n minus 36 is 4. Adding the 36 to both sides, 2n is 40. Dividing by 2, n is 20. Okay? Again, if I'm going over these and either maybe I'm doing it a little too fast for you, all right, or maybe you just need to see it again, your concentration gets broken. Mine got broken a couple of minutes ago making the video. So if that happens, just go back and watch this section over again. I think it'll help you understand. Okay, very similar, but this time it's an inequality and your extra graph at the end of it. Okay, so distributing the 5, that gives me 5n plus 15. Distributing the negative 3, negative 3n minus 9, less than 3 minus n. Same side, same operation. 5n's minus 3n's is 2n's. 15 minus 9 is 6. Less than 3 minus n. Always start with the smaller number of n's, so we add it to both sides. 3n, and then we're going to, it should say plus 6 is less than negative 3. So let me go back and correct this one as well. Oh, God. And there. Okay, so let's go back to this guy. Ready? I had a sloppy mistake made in, but I was able to correct it now. Subtracting 6 from both sides, 3n is less than negative 9. Dividing by 3, n is less than negative 3. I like it because the n is on the left-hand side. And that allows me to do my graph, which looks like this. Strictly less than, so I don't fill in the circle. Negative 3, and as long as the letter's on the left, the arrow drawn from the inequality will match the direction of the inequality. All right, a little simplification kind of question here. So I would, if I were you, double distribute with the x minus 1, the x plus 7, also the 2x plus 5 and the x minus 1, but keep that separate with that minus sign. You'll see it coming up. Then distribute the 4 to the first product and then get all your terms together. Give it a shot, stop and start. Okay. So I double distributed the first one, got x squared plus 7x minus 7, and the second, 2x squared minus 2x plus 5x minus 5. Combining them, I get x squared plus 6x minus 7 and 2x squared plus 3x minus 5. And notice that I keep the right in parentheses because that subtraction or negative applies to all of those. So if I don't leave that grouping symbol there, then I'll think it only applies to the 2x squared. But it says here clearly to subtract or negate the product, okay? Distributing the 4, 4x squared plus 24x minus 28, and now distributing the negative to all three terms, negative 2x squared minus 3x plus 5. Combining like terms, 2x squared plus 21x minus 23. That's a nice question. It really shows a lot of different steps that you need to know how to do algebraically. Of course, we're using the same properties as an arithmetic because an algebra is just a fancy arithmetic. And you can see here that we have order of operations, PEMDAS, if you will, or please excuse my dead Aunt Sally, or dear Aunt Sally, depending on how your high school taught it. We have the idea of double distributing and then just single distributing. Graphing inequalities. Okay, graph all of these. I will show you the correct answers when you are done. Okay, so the other day we did this slide, and unfortunately I didn't have the animations working on it. So today we have the animations to make sure that you remember what's going on. N is less than or equal to 4. Looks like this. You fill in the circle because it's less than or equal to. Okay? Next one. N is greater than or equal to 4 or greater than 4. Ignore these bracket notations on the right. We're just doing the graph on this one. N is greater than 4 graphed. N is less than 4 graphed. N is greater than or equal to 4 graphed. Between -2 and 5, that bounded interval. Open circle at -2, closed circle at 5, and from 3 to 7, same thing. Okay? Now, let's take a look at the bracket intervals and go from the bottom up because I think I got the top one wrong. All right? This bounded interval from 3 to 7, you're allowed to equal both, so we use a staple or a bracket. If it's tricky for you to remember which is which, the bracket or staple, you can make an equal sign out of the top and bottom, so you're allowed to equal it. For the next one, from -2 to 5, that's a parenthesis at -2 and the bracket or staple at 5, because you're not allowed to equal -2, but you are allowed to equal 5. For the next one, you are allowed to equal 4, so we have a staple or bracket all the way out to infinity. Remember, you can never equal infinity, so infinity always has to be a parenthesis. Next, I'm less than 4, so that goes from -8 all the way up to 4. And here's the problem. You're not allowed to equal the 4, so this should be a parenthesis. And this guy here should be a bracket. So now, you can see I go from -infinity all the way on the left up to 4. I can never equal infinity, and I'm not allowed to equal the 4, so it's a parenthesis. The next one, I should have also corrected this. This goes from +4 to infinity. Let me correct that again. So I know it looks kind of unprofessional. I guess it is in a way, but you're also getting a chance to see how you could have done things the wrong way and versus the right way. And the corrections being done. I tend to think that I left the answers in an order from the other day and didn't go back and change them. Okay, so the second from the top, n is greater than 4. I'm not allowed to equal the 4 because it's an open circle. And then I go all the way up to infinity. Remember, you can never equal infinity. But the first one, you are allowed to equal the 4. Unfortunately, I need to correct this one also because I must have had these answers copied from the other day. So okay. One more time. I appreciate your patience. Oh, there we go. So this goes from 4 to infinity. This choice here, n is greater than 4. And then the top one goes from -infinity all the way up to 4. And you are allowed to equal 4, so it's a staple or a bracket. But you're not allowed to exceed 4. Okay, you try these two. Go ahead. I better have gotten these right. Graph them. Take the different notations and graph them on the number line. Do both. Okay, so the critical points are -3 and 4. I have an open circle on 3 and a closed circle on 4. For the next one, the critical points are -5 and 7. I have a closed circle on -5 and an open circle on 7. Differences between linear equations and inequalities is what that should say. Equations have only one answer. Inequalities have infinite answers. We talked about that the other day. A correct answer for an inequality must have the variable on the left, the symbol, and the number, not just the number. It's really important because there are infinite answers for an inequality. Can't fit them all on the number line, or on the answer space, I should say. If you switch sides, the arrow points to the same thing. We had one before, something like 9 is greater than n is less than 9. And if you multiply or divide by a negative, you must remember to switch the sign. Okay? There's the 9 is less than n is greater than 9. Scientific notation. What are we getting at with this? So everything we've done so far is a review. It's all spiraling the material. Again, I'll say this many times throughout the semester. I don't care how fast you learn. I care that you learn. Okay? Scientific notation. Why? Well, that number there is how many molecules are present in a cubic meter of space at standard temperature and pressure. Can you imagine doing calculations with that number, even with a calculator? I mean, how do you keep track of how many zeros you pressed? That'll drive you crazy. So years ago, mathematicians and scientists both understood that you could work with the scientific notation, and instead of writing all these zeros, you could just use the laws of exponents. So that's what's so great about it. Now, the standard format for scientific notation is a number between 1 and 10. It can equal 1. It cannot equal 10. It must be less than 10. Times 10 to the n, where n is the number of decimal places that we're dealing with. Okay? That number that we started with at the top is 6.023 times 10 to the 23rd. How do I get 23? Well, follow my cursor here. Ready? It's kind of like the cartoons. 3, 6, 9, 12, 15, 18, 21. And I have to create a number between 1 and 10. 602 is not between 1 and 10. Go one more place, 22. That's 60. That's not between 1 and 10. Go one more place, 6.023. That is between 1 and 10. And altogether, I moved 23 places. So the 23 places is the exponent, and then the number I get in the front, 6.023. That, by the way, is a very famous number called Avogadro's number. I haven't studied it in probably about, let's see, I'm 61 years old now. I haven't studied it in 43 years, but I still remember Avogadro's number. Operating with scientific notation is often quicker and easier than using a calculator, and less likely to make a sloppy mistake because of all the time, how many times you got to press 0 and so on. And then you just use the laws of exponents. So again, the consistency of math, the logic and the reasoning is to take these laws of exponents and apply them to problems that involve, real world problems that involve atoms and so on and so forth, used in something like chemistry or physics. You could use it as well. Multiplying and dividing numbers in scientific notation. Let's do 2.2 times 10 to the 5th times 4 times 10 to the 8th. Now, first, I know for a fact that you have seen scientific notation before, and everything I just discussed with you should be well known to you. Now it's a matter of operating with it, and in my experience, not everybody remembers how to operate with it. So, remember how with the laws of exponents we had multiply coefficients, add exponents? Well, same exact thing with scientific notation, because there's a coefficient in front, in this case the 2 and the 4, and there are exponents, in this case the 5 and the 8. So you multiply coefficients, you add exponents, 8 times 10 to the 13th. Man, is that quick. Very, very, very quick. Way quicker than lining them all up on a piece of paper. So immediately you have this very quick, very practical way of dealing with numbers. Write them in scientific notation and multiply according to the laws of exponents. Next one, 5 times 10 to the 5th times 3 times 10 to the 9th. Now this is a little bit different because when I do 5 times 3, I get 15, again, multiplying coefficients, and then adding exponents, 10 to the 14th. But what's different about that is you, in scientific notation, you have to have a number between 1 and 10, and that says 15. 15 is not between 1 and 10. So we make a subtle little adjustment for it. To change 15 to a number between 1 and 10, I have to take the decimal that's after the 15. I know we didn't write it, but it's there. Go back one space. And in going back one space, I get 1.5. But to move it back one space, I had to divide by 10. Okay? Dividing by 10 to go back one space. So then, in order to keep the value the same, I have to multiply by 10. That gives me 1.5 times 10 to the 15th. Why 15? Because when I multiply by 10, that's 10 to the 14 times 10 to the 1, which 10 is. Add exponents, you get 15. I have to have a number between 1 and 10 in the beginning, or it's not scientific notation. That's like the trickiest part of the whole subject matter that we cover. So 1.5 times 10 to the 15. Multiply coefficients, add exponents. All right, let's try again here. 3.5 times 10 to the 10th times 7.7 times 10 to the 8th. Go ahead. Okay, so I multiply those coefficients and I add the exponents. That gives me 26.95 times 10 to the 18th. But remember, 26.95 is not between 1 and 10. So I have to divide that by 10 to move that decimal one place to the left and make it 2.695. So to balance that out, I have to multiply by 10 on the right. See, take any number, right? Like let's take the number 20. If I divide it by 10, I get 2. And then if I multiply it back by 10, I get back up to 20. So when I move the decimal and divide by 10 here to make it 2.695, okay, that divided by 10, but I can balance that out, in effect not change the answer if I then multiply by 10. And that gives me 2.695 times 10 to the 19th. So in dealing with scientific notation, to kind of summarize here, we are going to multiply coefficients, add exponents. Very predictable. That's the laws of exponents. But we carry it one step further. If we happen to get a coefficient that's greater than 10, we will adjust that into a number between 1 and 10 by dividing the coefficient by 10 and multiplying the exponent by 10, which brings it up 1. Now, what about if we should divide? Well, if I divide here, I think, according to the laws of exponents, it should be to divide coefficients and to subtract exponents. And that's exactly what you're going to do. However, we get a little bit different here. 2 divided by 4 is 0.5, and then subtracting exponents times 10 to the 7. Now, 0.5 is not between 1 and 10 either. It's too small. So I have to make it bigger. Now, before I divided, move the decimal to the left. Now I need to move the decimal to the right, which is multiply. So I'm going to multiply 0.5 by 5. That gives me, multiply 0.5 times 10. That gives me 5. But since I multiplied the 0.5 by 10, I have to divide the 10 to the 7th by 10, which means 10 to the 1st. So I have to reduce the exponent by 1. And I go from 10 to the 7th times 10 to the 6th. So it's always this way of translating numbers into scientific notation. You will always do the opposite to the 10 that you did to the coefficient. If you multiply the coefficient, like in this case, you divide out, which means bring that exponent down 1. If you had multiplied, as in the previous slide, then you would go up 1. Okay, give it a try. Okay, I'm assuming you're doing stop and start here. Again, divide coefficients, subtract exponents. 2 divided by 8 is 0.25 times 10 to the 5th when we subtract the exponents. 0.25, however, that's not between 1 and 10. I need to multiply that by 10. That moves the decimal to the right. Right? Whenever we move the decimal one place to the right, we've multiplied by 10. But then I have to divide the 10 to the 5th by 10. Divide, subtract exponents. So going down 1 there, and I get 2.5 times 10 to the 4th. Okay? All right. Now, adding and subtracting numbers in scientific notation. I wish I had a better way for you. You just have to write it as a standard numeral, making sure you line up the decimal. So if I do this one, 3.7 times 10 to the 4th plus 2.08 times 10 to the 5th, The only way to do it is to write it as a standard numeral, right? I start with 3.7 and 3.7, so decimals here. I move it 4 places. 1, 2, 3, 4. And then I line up 2.08 times 10 to the 5th, right? 2 and then 0.08, and then 1, 2, 3, 4, 5. And then I add them. And I get 0, 0, 0, 5. Bring up the 1, 4, 2. That's 2.45 times 10 to the 5th. So I wish I had a better technique for you here with adding and subtracting, but there is no better technique. That is because whenever we add or subtract anything on the face of the earth, no surprise coming here, got to get your like things together. Okay? All right. Let's try the next one. Go ahead. So, 3.7 times 2 times 10 to the third is 3,720. 2.08 times 10 to the fifth, same as before. Add them up. 0, 2, 7. Ooh. 0, 2, 7. Oh, 3 and 8 makes 11. Bring up the 1. Bring 1 there and 2. That's 2.11772 times 10 to the fifth. Okay, so adding and subtracting, it is what it is. You gotta get like categories together. In order to figure out what the categories are, you gotta write them as standard numerals so that you can get your ones with your ones, your tens with your tens, your hundreds with your hundreds, and so on. Now we got that was my dog. Sorry. What matters? Next, fundamental theorem of arithmetic. What does this say? Well, it says that every positive integer has its own unique prime decomposition or factorization. What's a prime decomposition? Factorization. Well, this is something you did back in elementary school and maybe in middle school, and it is helpful for algebra later down the line. So I figured we'd take a moment and sidestep and cover this. Ready? 80. Pick any two numbers in the world that divide into 80. I picked 8 and 5. Now, 5 is a prime number. Now, remember, a prime number is a number that can only be divided by 1 in itself. Okay? Its only factors are 1 in itself. By the way, 1 is not a prime number. That's by definition. And 2 is the only even prime number, right? Because the only way to make 2 is 1 times 2. But 8 is not a prime number. Does anybody remember what we call a number that's not prime? That's called composite. So I break down 8 into 4 times 2. Well, 2's prime. That's excellent. 4 is not prime. So I go 2 times 2. Now, every number at the end of these branches are all prime. 2, 2, 2, and 5. So I have 3 2's there, and I'm multiplying. So that is... I'm wondering where my fourth 2 comes from. 8 times 5. 8 is 4 times 2. Oh, it's 80. Let me do a correction here. This is what I get for not beta testing this. But you know what? I'm horrible at doing slides. So, or horrible at editing. So 16 times 5, 4 times 4, 2 times 2, space, 2 times 2, and there, and back to this playing from current slide. And here we go. 80 is 16 times 5. 16 is 4 times 2. This other here, and altogether, I don't know what happened, but I get 2 times 2 times 2 times 2 times 5, which is better known as 2 to the 4th times 5. That's a little sloppy to say the least. Try 45. I think we'll do a better job on this one. Go ahead. Okay, 45 breaks down to 9 times 5. 9 breaks down to 3 times 3. So what do I have here? I have 3 times 3 times 5, which is better known as 3 squared, right? 3 times 3 is 3 squared, exponent 2 times 5. Okay, one last problem to do. Let's try 126. Okay, so That would be 63 times 2. It doesn't matter what numbers you start with. You always end up at the end the same. 63 is 9 times 7. 2 is prime, 7 is prime, but 9's composite. So I break 9 down into 3 times 3. Both of those are prime. So I am completely done. Everything's down to prime numbers. That's what you're decomposing it to, just prime numbers. So that's 2 times 3 times 3 times 7, which is 2 times 3 squared times 7. So that's the fundamental theorem of arithmetic, that every positive integer has its own unique prime decomposition. And where you really get to use that a little bit later on is in figuring out things like greatest common factors and least common multiples. Okay? All right, the next step, the last part of today's lesson, is talking about word problems. So the first thing we always want to do is read the problem carefully. You can read it once or twice, whatever you want to do. And then the next thing you want to do is you want to underline all of the important things. Very important to underline, and they don't put it as a step here, but you want to underline all of the important things in the problem. That in turn will help you write the equation that you translate to, or that's being modeled in the problem. Then you solve it. Okay? So make sure that you underline or highlight anything you think is important in a word problem. Okay? Make sure you use whatever's underlined. Anything, if you underline it, it's important. It better be used in that equation. So an example. 4 subtracted from 6 times a number is 68. What are some of the important things there you might want to underline? Well, 4 subtracted from 6 times a number is important, and it equals 68. Subtracted from. Let me ask you a question. If you go to Los Angeles from New York, where did you start? We started in New York, right? You went to LA from New York. So whatever is from goes first. If you go from Canada to America, you started in Canada. From always goes first. So always remember, from goes first. You are subtracting from 6 times a number. So that goes first, 6 times a number. Subtract 4 is 68. So 6n minus 4 is 68. Add 4 to both sides. 6n is 72. Divide by 6, and I get n is equal to 12. That's the correct solution. Okay? So again, underline. I didn't do it there, but you should do it. Underline everything you think is important, and use up everything that's underlined, and then you know you're doing it right. Okay, you try this one. Stop and start, of course. So remember, important tidbit from the last lesson card, from goes first. So 5 times a number goes first, 5n. Minus 8 is 67. Adding 8 to both sides, 5n is 75. Dividing by 5, n is 15. Okay? Let's try the next one. Okay, 4 less than a number divided by 3 is negative 9. Important stuff here to underline. 4 less than a number divided by 3, and then, of course, that it is negative 9. So, 4 less than a number divided by 3. Less than. Whenever we talk about a phrase more than or less than, we always switch orders, okay? Bruce Springsteen has this song called The Ghost of Tom Joad. And in the song, he has this line, it actually comes from the Bible, or he's quoting the Bible, where he says, "Waiting on the day when the last shall be first and the first shall be last." Well, whenever you see more than or less than, think of that song, "Waiting on the day when the last shall be first and the first shall be last." So you take what's last, the number divided by 3, and put it at first, and take what's first, the 4 or less than, and make it last. So n over 3 minus 4 is negative 9. Adding 4 to both sides, n over 3 is equal to negative 5. Then I multiply both sides by 3, and I get n equals negative 15. Okay? Remember, more than or less than, switch the order. Last shall be first, first shall be last. All right. Sum of 3 consecutive odd integers. This is going to get just a little interesting. How do you represent odd integers? Well, think about your favorite odd integer. I have 2 favorites. I have like 3 and 7. So let's go with 3. What's the next odd integer? Well, it's 5. How do I go from 3 to 5? I go up 2. And then from 5 to 7, I go up another 2, so altogether I've gone up 4. So that means for 3 consecutive odd integers, we can represent them by x, x plus 2, and x plus 4. And this problem talks about the sum. So that means add them up, and I get 45. So the first one, which is x, plus the second one, and I underlined it so that you would see that that's the second one, x plus 2, plus the third one, there it is, x plus 4. Add those 3 up, you get 45. This is a same side, same operation situation. 3x plus 6 is 45. Subtracting the 6, 3x is 39. Dividing by 3, x is 13. Oh, what are we asking for, as Mr. Braze would say? Well, 13 is the first one. The next one is 15, and the next one is 17 because the problem said find the integers. Okay? Try this one. Okay. Sum of 3 consecutive evens. If it's consecutive evens, just like odds, it's x, x plus 2, x plus 4, because like you could take a favorite odd number, like even number, sorry, like 10, and the next one's 12, so you go up 2. The next one's 14, you go up another 2. So consecutive even and consecutive odd are the same exact thing. Sum means to add. So it says twice the first. So the first is x. Twice the first, look at it underlined here. Twice means 2 times x. And the last one's x plus 4. So there's twice the first plus the last is equals the second one, which is x plus 2, increased by 42. All right, so twice the first plus the last is the second one increased by 42. Same side, same operation here. 3x plus 4 is equal to x plus 44. Subtracting x from both sides, I get, because now it's opposite side, opposite operation situation, 2x plus 4 is 44. Subtracting the 4, 2x is 40. Dividing by 2, x is 20. Okay, big benefit. X is going to equal 20. It wants to find the integers, so that's 20, 22, and 24. Okay, let's try the next type of problem. One more consecutive integer. Now, before you start this one, consecutive integer, pick your favorite integer. Let's say 7. What's the next consecutive integer? It's 8. Then the next one, 9. So I go from 7 to 8. That's up 1. So it's n or x, n plus 1, or x plus 1, n plus 2. Go ahead. Okay. N plus 1, and n plus 2 are the 3 numbers, or represent the 3 numbers. Twice the second, there it is, twice the second, increased plus 3 times the third, there it is 22 more than 3 times the first. 22 more than 3 times the first. Distributing 2n plus 2 plus 3n plus 6 is 3n plus 22. Now it looks like the equations that we did the last couple lessons, all right? So this shouldn't be too hard on you. Same side, same operation, 5n plus 8. It's going to be 3n plus 22. Subtract 3 n's from both sides. 2n plus 8 is 22. Subtracting the 8, 2n is 14. N is 7. The numbers are 7, 8, and 9. Now we got a problem about taxis. Read it and see what you think. Remember, underline all of the important stuff, and then we have to make sure we use all of the important stuff. Go ahead. Final thoughts? Now, What's an expression for how much you pay? Well, it's $2, underline that, to turn on the meter, and 25 cents for each, not mile, but eighth of a mile. We're going to have to come back to that a little later on. If you have $10, how many eighths of a mile can you go? So 2, the whole number 2, because just to turn it on, plus 0.25 or 25 cents for X. And X is the number of eighths of a mile. And then how many miles is that? So $10 is 0.25X plus 2. Subtracting the 2, I get 8 is equal to 0.25X. Then I divide by 0.25, and I get X is equal to 32. So how many eighths of a mile is that? Or is 32 eighths of a mile? That's what X represented. And if I divide that by 8, because it's 32 eighths, you get 4 miles that you can go. Okay? I think we got another one of those for you here. There you go. Give it a shot. Okay, so expression for how much you pay, just like before. 0.25x, oh, it should be plus 3. Oh, let's do a little bit of beta testing here. Oh, the good news is that I had it correct in the equation. 0.25x plus 3. And this time you have $12. So 12 is 0.25x plus 3. Subtracting the 3, I get 9 is equal to 0.25x divided by 0.25, and I get x is 36. So I have 36 eighths of a mile. So I divide that by 8, and that gives me 6. It doesn't give me 6. It gives me 4.5 miles. I don't know why I have a 6 there. It's 4.5. Next up, a little bit of a percent type of problem, okay? After a 40% reduction, an exercise machine sold for $564. How much was the machine before the price was reduced? Go ahead. Okay, so if you've reduced the price 40%, then 60% remains, okay? So 60% of the original price has to be the remaining price, which is $564. Now, of in mathematics means to multiply. So 60% of the original price, call the original price N. 60% of or multiply N has to be 564. So whenever we do percent problems and we're working them out in algebra, we always make sure we write it as a decimal. So 0.60 N equals 564, divided by 0.6, which is the same thing as 0.60, and I get N is $940. So the original price of the machine was $940. What we're looking for here, and I forgot to say it on this one, I apologize, and maybe the previous one, get into the practice of underlining. 40% reduction is important. Sold for $564. I don't care that it was an exercise machine. For all I care, it could have been a set of golf clubs. Bottom line is, after 40% reduction, price $564. Underline all of that. Make sure you include it in how you set your problems up. Another percent word problem. Go ahead. All right, so another way students like to do percent is a lot of students were taught to do percent over 100 equals part over whole or is over of, okay? So percent over 100 equals part over whole. And this makes sense because percent means out of 100. So the percent is the part out of a whole of 100. So 15%, so I put the 15, underline that in the percent place, and 800 people, very important. I put that in the whole because there were 800 people in the population that you're talking about. So 15% were sampled out of the whole thing, which is 800. I get 15 over 100 equals n over 800. Cross multiply, right? N times 100 equals 15 times 800. And I get 100. N equals 12,000. Dividing by 100, and I get n is equal to 120. Now, I'm doing some assuming in these last few slides here. I'm assuming you know what cross multiplication is. I am assuming you know that if you spend 60% then you reduced it 40%. If those percent concepts are difficult for you, make sure you reach out for some office hours help, and I will remind you of the basics of percents. Perimeter word problems. Do this one, and one thing that's real important with perimeter word problems, I feel, is to always draw a diagram. So we have 2 more of these perimeter word problems left, and then we wrap up today's lesson. Okay, so here's my diagram. Remember, less than, switch the order. Last shall be first, first shall be last. One side is W, the width. The other side is 3 less than 4 times the width. So switching order, 4W minus 3. So that is the length and width of the rectangle. Got to go find it. If I add up the left side, the top, the right side is also W, and the bottom, which is also 4W minus 3. Perimeter means the distance around. That's why I added those. I get 44. So 10W minus 6 is 44 because it's the same side, same operation situation. Adding 6 to both sides, 10W is 50, dividing by 10, W is 5. And the length is going to be 4 times 5 minus 3, and that's 20 minus 3, or 17. What's the area of the rectangle? 5 times 17, right? Length times width. 5 times 17 is 85. Okay, you give it a shot. Again. Okay, length of a rectangle is 5 less than 3 times the width. So remember, last shall be first, first shall be last. That's 3W minus 5. And here's a W here for the width. And then it wants to talk about the perimeter. So if I add up all the sides, a W, a 3W minus 5, those I see, and then another W for the right-hand side, plus another 3W minus 5 for underneath that, is 62. So that gives me, same side, same operation, 8W minus 10 is 62. Add 10 to both sides, 8W is 72. Dividing by 8, I get W is 9. The length would be 3 times 9 minus 5, which is 22. What's the area? Well, that's 22 times 9, the length times the width. And that gives me 198. Okay? All right. Now, that represents our last word problem of the day. And we will do word problems pretty much daily, just about from now until the end of the school year. So if you didn't understand all of the word problems today, don't get upset. Just remember, underline everything that's important to you that you can use in the word problem, and then make sure that you've used it. I even go a step further and put little check marks next to everything that I underline so that I know I've used it. The happy recap, we say that because years ago, I am a Met fan still. And years ago, they had an announcer named Bob Murphy, and whenever the Mets would win, he would say, "And now for the happy recap." Fundamental theorem of arithmetic says every positive integer has its own unique prime decomposition. With word problems, underline anything important and use it. Check it off as you go along. Scientific notation can be helpful. Just follow the laws of exponents and what you have learned about how to add or subtract anything in the universe. In other words, do what you already know. Okay? All right. Last but not least, a reminder of how to succeed in class, because we want that for you. Our course is 8 weeks long. We finished before today about a quarter of the work in the class. So let's keep going and make sure that you succeed. How? Do all that homework. It's 10% of your grade, kind of like extra credit. How you go about your business is critical. It really does define who you are. One of the things, I'm very proud of both of my sons, but one of the things I am most proud of is that anyone they have worked for have always come up to me and said, "Bob, your sons have a fantastic work ethic." And they say, "Hey, a lot of younger people these days don't have that work ethic. Your kids do." So you're always going to be okay if you have a great work ethic. Pay attention to due dates in Moodle. You don't want to miss when something is due. It's bad for your grade. Work together on projects. Collaborate and take pride in your work. Every day is a chance to realize your dream or not. Because if you don't progress, then you're not realizing your dream.